How air became the most complex chemical system on Earth. It feels empty, invisible, weightless, yet air is the most active chemical system surrounding human life. Every breath interacts with thousands of reactions already in motion. Air was not always like this. For much of Earth's history, the atmosphere was hostile. No oxygen, no protection, no balance. What exists today is not natural by default. It is engineered by chemistry over billions of years. To understand why this matters now, we need to stop thinking of air as background. Air is not a container. It is a reactor, a constantly mixing, reacting, evolving system that supports life only within narrow limits. Modern civilization depends on those limits remaining stable, and they are more fragile than they appear. The first narrative beat begins with simplicity. Early Earth's air was dominated by volcanic gases, carbon dioxide, methane, ammonia, reactive and unstable. Energy moved freely. Life could not survive long at the surface. The chemistry was too aggressive. Then something changed. Tiny organisms began releasing oxygen. At first, oxygen was toxic. It reacted violently with existing compounds. Iron rusted across oceans. Energy pathways shifted. The atmosphere transformed from reducing to oxidizing. This was not gradual. It was disruptive. That is the first major transition. Oxygen did not just add to air. It rewrote every reaction occurring within it. Combustion became possible. Ozone formed, shielding life from radiation. Energy could be extracted efficiently. Air became structured. The second beat follows with balance. Nitrogen diluted oxygen's reactivity. Inert gases stabilized reactions. Water vapor regulated temperature. Greenhouse gases trapped just enough heat. Each component moderated the others. Complexity emerged from restraint. The third beat is subtle. Air became alive with cycles. Carbon moved between atmosphere and biosphere. Nitrogen fixed into soil, then released. Oxygen consumed and regenerated. No component stayed constant. Stability emerged from motion. From the outside, air feels static. From the inside, it is constant negotiation between radiation and heat, between reactivity and restraint, between chaos and balance. And this is where the story begins to sharpen. Because the more complex air became, the more sensitive it grew. Small changes now ripple across the entire system, and humanity has begun altering it faster than chemistry can comfortably absorb. As air grew more complex, its reactions became interdependent. No molecule acted alone. Every change triggered a response somewhere else. This is what transformed atmosphere into system. Oxygen enabled life, but it also demanded control. Too much, and fires would dominate landscapes. Too little, and energy production would stall. Nitrogen stepped in as moderator. It diluted oxygen's reactivity. It slowed combustion. It stabilized breathing chemistry. Air learned restraint through balance. Water vapor added another layer. It absorbed heat during the day, released it slowly at night. Clouds reflected radiation. Rain redistributed chemistry across the planet. Temperature stopped swinging wildly. Habitability emerged from moderation. Carbon dioxide played its part carefully. In small amounts, it trapped heat, enough to prevent freezing, not enough to cause runaway warming. This narrow window allowed oceans to stay liquid. Life flourished within that margin. Air became forgiving, but only barely. The chemistry of air now depended on cycles. Plants removed carbon dioxide. Animals returned it. Microbes processed nitrogen. Lightning fixed it. Everything fed back into everything else. Air stopped being a mixture. It became a living equation. This is where the early conflict appears. Because complex systems are efficient but fragile, they work beautifully within limits. Outside those limits, reactions accelerate unpredictably. Small additions create outsized effects. Air responds faster than intuition expects. Modern emissions exploit the sensitivity. Extra carbon shifts heat balance. Extra nitrogen alters ecosystems. New compounds introduce unfamiliar reactions. The system does not reject these changes. It incorporates them. And incorporation changes behavior. Smog forms from sunlight and pollution. Ozone appears where it does harm. Particles alter cloud formation. Rain chemistry shifts. Each effect feeds another. Air is no longer just reacting. It is amplifying. What nobody expected was speed. Changes once spread over millennia now happen in decades. Feedback loops activate before buffers can respond. The same complexity that once protected life now magnifies disruption. This is the tension at the heart of the atmosphere. Air became complex to support life, but complexity demands careful pacing, and humanity has begun pushing reactions faster than balance can restore. The system still works. Breath remains possible. Weather still follows patterns. But chemistry is drifting, and drift in a complex system is never trivial. As atmospheric chemistry drifts, stability begins to fracture, not everywhere at once, but at pressure points where balance was already thin. Heat accelerates reaction rates. Warmer air moves faster. Molecules collide more often. Ozone forms where it should not. Pollutants persist longer. What once dispersed now lingers. Air chemistry thickens with consequence. This is where the conflict fully develops. Because the atmosphere is not uniform, reactions behave differently by altitude, latitude, and season. A change in one region propagates elsewhere. Jet streams shift. Weather stalls. Systems that once moved energy efficiently begin to hesitate. The buildup becomes visible through extremes. Heat waves trap reactive gases near the surface. Cold snaps destabilize circulation. Storms intensify as warm, moist air feeds energy upward. None of these are isolated. They are chemical responses to altered gradients. Biology reacts immediately. Plants open and close pores differently. Photosynthesis shifts timing. Respiration rates change. The balance between oxygen production and carbon release wobbles. Life adjusts, but at a cost. Efficiency drops. Resilience narrows. Human systems feel this next. Air quality degrades unevenly. Some regions breathe clean. Others accumulate toxins. Infrastructure struggles with new patterns. Energy demand spikes unpredictably. Health outcomes diverge. Chemistry becomes social. The most dangerous aspect is invisibility. Air looks unchanged. Breathing feels normal, but composition shifts by parts per million matter. At this level, chemistry decides outcomes quietly. Small ratios control massive systems. This is the moment tension peaks. Because the atmosphere is no longer forgiving. It still supports life, but it demands correction. Balance must be restored faster than drift continues. Otherwise, complexity becomes liability instead of protection. Air became complex to stabilize Earth. Now that same complexity amplifies imbalance. And chemistry does not pause while humans debate response. It continues reacting, waiting only for conditions to determine the next state. The climax is not suffocation. It is sensitivity. Air did not become complex to resist change. It became complex to balance it. Every molecule moderates another. Every cycle corrects excess. But that elegance comes with price. Complex systems respond sharply when pushed beyond limits. This is the final realization. The atmosphere is not breaking. It is adapting, shifting toward a new equilibrium that obeys chemistry, not comfort. If inputs continue to change, air will stabilize eventually. The question is whether that stability still supports modern civilization. The resolution is clarity. Air can recover, but only if reaction rates slow. Only if cycles are allowed to rebalance. Only if additions stop outpacing absorption. Chemistry does not require perfection. It requires patience. Modern relevance makes this unavoidable. Air connects everything. Health, climate, food, energy. Nothing escapes atmospheric chemistry. Every emission is an experiment. Every delay compounds results. The system records all of it. This reframes responsibility. Protecting air is not abstract. It is maintenance of a living system, one that took billions of years to stabilize and can be destabilized in decades. The scale mismatch is unforgiving. Once you see air as chemistry, it stops feeling empty. It feels active, responsive, vulnerable. a system that rewards restraint and punishes acceleration, exactly as physics dictates. How air became the most complex chemical system on Earth is no longer just history. It is a warning. Complexity sustains life only within limits, and those limits are now visible. Sometimes the smallest shift in perspective becomes the beginning of a new future. How